Welcome back to 4.3, and this is on circular geometry and velocities. With part 1 of this 4.3, we're going to talk about circular geometry. Circular geometry is talking about like parts of the circle, because this unit so far is all about trigonometry and how angles relate to a circle. So with a circle, some basic formulas that you might have learned back when you did some geometry is there's two main things we care about for a circle, like when it comes to calculations. Some values that we do know is like, let's undo that. Like this right here is the radius. And we know the radius, we've been using the radius, and radius does relate to radians. A couple things that we know about a circle is the circumference. Circumference is the perimeter of a circle. So the whole distance around, as I travel along this whole arc, this whole circle, how long does it take? And this is 2 pi r. Another thing that we might have learned before is the area of the circle. It is pi r squared. So this is something we might have seen before, maybe not, but I'm going to assume that we do notice, and these are given. We know this is a circumference of a whole circle, area of a whole circle. But now we mentioned whole circle, but we haven't really done much with whole circles in this class. We made a unit circle, but a unit circle is split up between angles. So let's erase that, and let's take this section right here. And I want to take a little section of this circle. Let's say right here as well, this section. So instead of, let's see how that relates to these two measurements. So circumference is my whole perimeter, but now I don't want my whole perimeter. I just want, how long is this arc? And we call this arc length. So I want to find the arc length. Arc length is related to circumference. Where circumference is a whole circle, arc length is just how long is this one arc. The arc could be the whole circle, but for this one, I just want this little arc. And likewise for areas for the whole circle, what we do instead is you find the sector area. So like we call this a sector, and I want like how big is this sector? Now let's try to divide these formulas. So whenever we talk about a whole circle equals 2 pi radians. That is what we know about whole circles. We use that quite often in our functions that we've been doing. Is like a whole circle takes 2 pi, like one full cycle takes 2 pi. So let's look at our formula and see, where do I see the 2 pi? In circumference, I see 2 pi right here. So if my whole circle is 2 pi, I don't want it to always be a whole circle. I want it to just be this part of a circle, this angle of a circle. And angles we've been denoting as theta. So therefore arc length, the formula for this is I want to get rid of the 2 pi, and I'm going to replace the 2 pi with theta. So what we're doing here is I want to get my 2 pi and convert it into theta. I see my 2 pi here, and I added theta instead. So my arc length equals theta times r. This is my arc length formula. And this makes sense because we want just a portion. We just want a portion of a circle. So let's make this circle, let's say a radius of 5. My circumference and a theta of, let's make it 2 pi over 3. So a third of the circle, because 2 pi is a whole circle, divide by 3. Circumference of this whole circle, 2 pi times 5, is 10 pi. That is my whole circumference. And seeing this, if I just take a third of it, my arc length should just be this divided by 3. So my arc length should be 10 pi over 3. Let's see if that is true with this formula. My arc length, I want it to be my theta, my 2 pi over 3, times my radius. We multiply this together, and we see it is true. Because what we did is we got our radius, not our radius, our whole circumference. I divided it by 2 pi, so I want to see how many of these do I multiply to each radian. And then convert that into, then I multiply it with how many radians I do have. So another way of seeing it is, I had this, so 2 pi r, I divide it by 2 pi, and multiply it by theta. So I get rid of the total whole circle, r times theta. And this is my arc length. Next up is sector area. We do the same thing with sector area. So sector area is pi r squared. So when I get this pi r squared, divide it by 2 pi, and multiply it by theta. The pi's cancel out, so I get r squared over 2 times theta. But the best way that we do write it is 1/2 r squared theta. And this is just my area, my sector area. You'll be given these for the exam, but these are 2 new formulas. And let's do a couple problems with this. The problems that you might see will range in difficulty, but since it's all we have are formulas, the difficulty of this comes from which formula can I use and being flexible using these formulas. As you do more and more, and we do the next part of 4.3, you'll see that there's a lot of repeating variables. And these repeating variables make it so add the difficulty of it. So we'll start off with the basic problems. I have a circle over here with an arc of, what should I make this? 3 pi over 7, and a radius of 4 inches. So to find the arc length, we make our formula. I was like writing my formula first, just so I didn't have it and get used to like slowly memorize it. Even though it's provided for me, I think memorizing it is still pretty helpful. So my arc length is equal to 3 pi over 7 times 4 inches. And for the most part in this class, I'll always ask you to leave it in terms of pi. So my arc length is 12 pi over 7 inches. And then my area, 1/2 r squared theta, 1/2 4 squared times 3 pi over 7. So 1/2 times 16 times 3 pi over 7. And this ends up with 3 times 16 gives me 48. 48 pi over 14. Reduce it down to get 24 pi over 7 inches squared. So we see in this scenario, we just plug it